Good morning. So at the end of last lesson, I asked you what skills you wanted to practice for the paper 2, the on-screen Python exam, and we said, can we practice reading data from a file? And we went through this code. You can access this at the top of Compete with Code for our class. So I just want to explain what we've got so far, and I'm giving the class at the moment a couple of minutes to work through these challenges. So we have some data that you suggested. Comma-separated value, a CSV file, but saved as a TXT file. It is just text. The name of an insect, and I think we had appearance, speed, and weight, or something like that. Let's see. Yeah, appearance, speed, and weight. So we've got a constant for the name of the file. We've got a function that takes one parameter, and we're calling that function with the constant, and the constant is just the name of the file here. The function gives a return value of data. Data is a two-dimensional list, as in a list of lists, and each list contains a string, that's the name of the insect, and then two integers, that's the appearance and speed, a rating out of 10, and then the weight, which is a float, and that's I guess it's in grams. We're just guessing these values. So each record, remember, we can't call this an array because it's mixed data types. They're not all the same data type. Each record with different data types in it, you can have multiple ones of those records within a two-dimensional list. That's what we want to try and do. So the code does work. We get all the data from a file in the right data types. Look, a string, two integers, and a float. However, we want to display it as a table. So how did we do this? Well, we open the file, and we store the file as a file object, and we must remember to close that file. We get one big long string containing the whole of the file when we do f.read. F is that file object. And we make an empty list that stores nothing to begin with so that we can add something in. We can append each individual record into that list later. So the next bit is about how do we get that data? Well, first of all, we split them up into lines. Every new line, as in there's a new line constant at the end of this line, a new line constant at the end of each line. So we want to split it and get a list here where each line is stored separately. Then we can iterate through that list, each line singular in the list of lines plural. We can split each line into columns because each value is separated by a comma. Look, there's a comma between each value. Then, once we've separated them out into columns, we can access the four values by looking at that list called columns. So the first is a name, the second and the third are both integers, appearance and speed out of 10, and then we convert. Remember, when we load from a file, all the data is a string, so that's why we have to convert it to an integer or a float. We put that into a list, we add that list into our two-dimensional data structure, which we've just called data, and then finally we return it so we can store it. Your job, can you iterate through data and display them on separate lines? That's quite easy. A little bit harder, can you use string formatting to display it as a table? And a little bit harder still, can you calculate the averages? Now, if this was a question 6, you would get marks for doing this using decomposition and abstraction. That means using subprograms. Maybe make another subprogram called calculate average. Remember, you get marks for easy things like comments and white space. So even if you don't know how to do any of these, make a good stab at it and include some comments and white space, blank lines, and you're going to get some marks. Okay, so we've had some time to have a go at challenge 1. Let's explore how to do that. We want to just display each insect on a separate line for now. So when we run it, we see the whole two-dimensional data structure. What do I mean by two-dimensional? I mean, we need two indexes to specify an individual data point. For example, this 8, we need to first of all know which list we're looking at, the first one, so index 0, and then which value within that record, which is the second one, so index 1. So if I wanted to just display the dragonfly, but if I only wanted to display the second value of that dragonfly, the 8, there we go, like that. So if I want to display them all on separate lines, remember we get marks for white space and marks for comments in a question 5 or 6 in the exam. Display all insects on separate lines. We're going to use a for loop. For insect in data, print insect. And that's it. Doesn't look very nice, but they are all on separate lines. Your job is to try and do it as a table. So I'll give you some tips to get started. But first of all, remember, you are allowed to use the PLS, and the PLS has been updated to include some extra detail about string formatting, which is exactly what we need. So on the VLE, you've got the PLS at the moment. The latest version is version 5. If we search for string formatting or just formatting, there we go. There's a nice page that guides us through how to do this stuff. That looks useful. So it's something like layout equals blah de blah, print layout.format, something or other. Okay. So this time, let's have all of these. So print, I'm going to have one of those multiplied by, I don't know, 20. Probably going to need a lot more than that. Then I want to display the titles. So, I don't know, names equals, I'm not going to do all of them, you can do the rest. Or titles, captions, titles. This sounds like a global variable to me. So let's put it up here. Insects, or headings, that would be better, wouldn't it? I can't remember which order. Appearance, speed, and weight. So then, let's see, show headings. Layout equals, so we need a string that specifies how we're going to do this. I've got a pipe character, and then something, another pipe character, which is just that thing there. It's shift and the button to the left of Z to get that. Another thing for weight, sorry, for speed, and another thing for weight. There we go. Print layout.format, and then I can put the values in. So what was that? Headings, 0 for the first one, and then 1. So let's copy and paste this. 1, 2, and 3. Will that work? Well, it kind of did, but it's showing insects for all of them because it's a 0 index for all of them, and I don't want that. So that should be the second one, the third one, and the fourth one. Better, but I want a bit of space. So maybe each column could be padded to, what, 10 characters? How do we do that? Let's have a look at the PLS. So width, we have a colon, and then the width. Let's just try that, shall we? So colon 10. That worked. But I want it center aligned. How do we do center aligned? The little up arrowy thing. Where does that go? Align. It goes up before the width. So if I put a little shift 6 thing in there, better, but probably needs to be wider. So let's make it 15. Aha! Now we're talking. So let's just do that for all of them. And then we're going to need a lot more of these. So if we've got 15, 15, 15, 15, that's going to be 60 plus all of these spacer things. So probably about 65 is my guess. Oh, look at that. Right, your job, now that we've got a bit of an example here, can you add a for loop to go through each value? Oh, didn't mean to do that. There we go. And then put all of these underneath. I'll give you another 5 minutes. Right, so we've had a little bit of time to look at this. We want to make sure that we're displaying each record on a separate line in this same kind of string formatting. So let's have a little bit of white space and another comment. show each record or show each insect. For insect in data, remember data is our two-dimensional list. We could just print insect, but it won't be displayed nicely. There we go. And we could do something very similar to this. So we get just the headings in the right place. And instead of headings, we could say insect. Double click, Control C, Control V, Control V, Control V. It bugs me that there aren't spaces here. There we go. So we got the right data, but it's not quite right because I said I wanted 2 decimal places. So we're going to have to change something. This layout is fine for most of them, but this one is wrong. So how do we do to 2 decimal places? After the width, we can do dot precision and type. So if we do dot to F for fixed point, that should work. So does that go after the width? Let's see, dot to F. Oh, look at that. It works. So do get familiar with the PLS. They give you so much help here in the programming language subset. PLS. And then all we need to do now is just copy and paste the bottom bit, which is this. But I don't want to do that after every record. I want it outside of the loop so it goes down at the bottom. And then we've just got challenge 3. Can you calculate the appearance, speed and weight and show them under the table to 1 decimal place? My tip here is, can we define a new subprogram called calculate average, and you give it 2 parameters probably, which column you want an average of and which data you're going to look in. Give you another 5 minutes. All right, so let's go through the final challenge. This one, there's lots of different approaches to this. You might have done it in a different way. I want to try and do this, first of all, without using procedures and functions. So let's try and work out the average appearance. So what is that going to be? Well, we start off with, I don't know yet. Let's see. Total is going to be 0. And then for insect in data, for all of them, the total can increase by, that is the second value, isn't it? That one. And then we can do the total divided by however many insects we've got. Oops, length of data. So no errors, and we should hopefully be able to see the average appearance. There we go. Oops, have I spelt it wrong? Yeah, appearance. There we go. Does that look sensible? There should be, yeah, that looks about right to me. However, if we ended up doing this for appearance, speed and weight, we'd end up with quite a few things that were duplicated. We'd just do something like this. Average speed and then average speed, which works but seems inefficient. Wouldn't it be nice if we could have something like just average appearance equals, and then calculate average. Well, what do we want to make an average of? The data. Which column do we want to take an average of? 1. And then we can just repeat that and say average speed and average weight. Obviously, it doesn't know how to do that yet. We haven't told it how to calculate the average. But that would be really nice. Because then we can do abstraction. We can hide away the unnecessary detail and say, just do that for me, please. This means that we need to define this behavior. So I'll pause the video for the answer to the question, but is this a procedure or a function, and how do we know? Yes, the answer is it's a function because it returns a value. So let's define a subprogram. Def, we need to give it a name, calculate average. The argument is data, and the other argument is 1. So the parameters need to describe what that is. We'll have a parameter for the data we want to analyze and a parameter for the column number. And then we can do what we did before. Total starts at 0. For each row in pdata, oops, that should say 0. Total is going to be, all right, I'm going to pause it now and you're going to tell me, what do I want to add on to the total to keep a running total of all the values within that particular column? Yes, well done. pdata is the name of the parameter. In our case, the argument is data, and data stores all of our insect data. pdata, actually the answer wasn't right. We need to know which column we're interested in, but it's not going to be pdata here because pdata is a two-dimensional array and we're only giving one index. So that is not the right answer. Look, we'll get an error here because it doesn't know how to add a list to an integer. So we've changed pdata to row instead. Why? Because we're iterating through each row in pdata. Row is a one-dimensional list. pdata is a two-dimensional list. That should work. However, this is currently a procedure. In order to make it a function, what do we need to do? I'm going to deliberately do this wrong. It looks like it's worked, but what's wrong with this? So at the moment, this is breaking out of the function as soon as we've done the first insect, dragonfly. I want to wait until we've gone through every row after the stick insect, and then we return. So now, hopefully, we can display these. Let's do something like that, but this time we can put in the just the text average and then average appearance and average something else. What is it? Speed next. And then finally, hopefully, average weight. Oops. Will it work? Yes, kind of. However, we said we wanted just one decimal place. And I want a line on the end. So what do I change here? What do I add? What needs to change to make all of these one decimal place? And is that right? That doesn't look right to me. Oh, there's a logic error in here as well. Have you spotted it? And what can we do differently? So well done. I didn't spot that. Average weight. We've said the index 2. We want index 3, but it still doesn't fix it. It looks like we've got a total, not a mean average. So yes, we need to divide by the length of the list. So return total divided by the length of pdata. That's better, but we've got two decimal places, not one. So last logic error. What can we change to finish everything off? So I've copied and pasted this down here. I'm going to change the 15.2f to 15.1f. That works here, but it hasn't worked here. So I just need to put the .1f in all of the others as well. I wonder what will happen if I do .1f. It says nan. Nan is not an insect. Why is that happening? Because we're taking a string and we're trying to do a string to a floating point number, which doesn't make any sense. That's much better. I reckon we've done it. So I've just sent a link to the same code. I'll put this on a link in the video that I'm sharing in the description so that you can choose whether you do keyword comprehension. For example, can you find where you're passing data out of a function? That will be the return value. Or do you want to practice debugging it? Each time you press sabotage or the first time you load it, there'll be 5 errors. Click on the code, Control Enter. It could be a capitalization problem. It could be a syntax error. Ooh, interesting. Will it work? Come on. Yeah, but it might not have worked properly. This doesn't look like it's to one decimal place. Sorry. Why is that not working? Ah, because it's another capital L there. There we go. That's better. Or you could try writing your own code that does all of these challenges. It's your call. So we haven't done any CT or P worksheets today. All we're going to do between now and the end of the lesson is make sure that we've understood how to load data from a file, and then we'll go through some of the past paper material on the VLE, or just practice getting familiar with the PLS. So just a reminder, the PLS is on the VLE, there it is, and the practice paper material is down at the bottom, and it's a paper 2 that's coming up next. That's what you need. All the best. Thanks for your hard work.